On the morning of March 16, 1943, Captain Lieutenant Werner Hartenstein sat in the conning tower of U-156 and watched the horizon with the particular stillness of a man who has learned that the ocean will kill you the moment you stop paying attention. He was 34 years old, a career naval officer from Plauen in Saxony who had joined the Kriegsmarine in 1928 and who had spent the better part of 3 years turning the North Atlantic into a German honey. In ground, he was not a cruel man. He was not a reckless one. He was precise, methodical, and extraordinarily good at his work, which was the location and destruction of Allied shipping in the waters between North America and the British Isles. He had reason to be confident that morning. The Wolfpack operation he was part of, a coordinated attack on convoy HX IT-9 and SC-1-2 to large Allied convoys moving northeast across the Atlantic, was already being called the greatest convoy battle of the war. 21 U-boats had been operating against those convoys for 3 days. 21 ships had been sunk. The tonnage destroyed was staggering. In Berlin, Admiral Karl Dönitz, the commander of the U-boat arm, was watching the reports come in with the quiet satisfaction of a man whose strategic vision was being vindicated in real time. The Atlantic, Dönitz believed, could be won. The numbers said it could be won. The convoys were bleeding faster than they could be replaced. The math was on Germany's side. Hartenstein checked his instruments, scanned a horizon, and prepared for another attack run. He did not know that the math was about to change. He did not know that 400 miles to the southwest, a ship he had never seen before was making 24 knots through heavy seas toward his position. He did not know that this ship carried equipment that did not yet exist in any manual his training had prepared him for. He did not know that the name of this ship class would become, within 18 months, the 2 words that U-boat commanders whispered to each other in the harbors of Lorient and Brest with an expectio, and that veteran sailors reserved for things they had decided were beyond their ability to defeat, destroy, escort. Hold that phrase, hold it the way Hartenstein was holding his binoculars that morning, not knowing what was coming, not knowing that the instrument in his hands was already becoming insufficient for the world he was about to enter. Because to understand why that phrase became the most feared 2 words in the German submarine service, you first need to understand what the North Atlantic looked like before those ships arrived. What it looked like when Germany was winning. If you are watching this kind of deep, documented WW to history for the first time, hit subscribe and the like button now. It helps these stories reach the people who care about remembering what happened out there on that ocean. The Battle of the Atlantic was the longest continuous military campaign of the Second World War. It began on September 3, 1939, the day Britain declared war on Germany, when U-30 sank the passenger liner Athenia without warning in the waters west of Ireland. It did not end until May 8, 1945, the last day of the war in Europe, when the final U-boat kills were recorded in waters that had been a killing ground for nearly 6 years. In those 6 years, German submarines sank 2,779 Allied ships, nearly 15 million tons of cargo sent to the bottom of the Atlantic, food, fuel, ammunition, tanks, aircraft, medicine, the entire industrial output of North America attempting to cross 3,000 miles of open ocean to sustain Britain and supply the Allied armies, and German submarines waiting in the dark water beneath to destroy it. The men who fought that campaign from the German side were not the cartoon villains that wartime propaganda made them. They were young, professionally trained, extraordinarily brave, and operating under conditions of sustained physical and psychological stress that few military experiences in any war have matched. A U-boat crew lived in a steel cylinder roughly 67 meters long and 6 meters wide. They shared that cylinder with 50 other men, with diesel engines that filled the interior with fumes when running on the surface, with electric motors that depleted their batteries every time they submerged, with torpedoes and spare parts and food supplies packed into every available space, and with the constant knowledge that the ocean outside was not merely indifferent to their survival, but actively hostile to it, the pressure hull of a Type V U-boat. The workhorse of the German submarine fleet was designed to withstand depths of approximately 200 meters. Experienced commanders pushed deeper when they had to 120 meters, to 140 meters. Knowing that every meter below the rated depth brought them closer to the point at which the hull would implode, they knew what implosion meant. They had seen it happen to other boats. The sudden silence on the radio, the absence of a return to port, the name added to the list of boats on eternal patrol. The phrase eternal patrol was the German Navy's way of saying that a crew of 50 men had died in a steel tube at the bottom of the Atlantic and would remain there until the ocean itself ended. By the spring of 1943, roughly 40% of all U-boat crewmen who had gone to sea since the beginning of the war were dead. That number was not publicly known in Germany. It was known in the Kriegsmarine. It was known in the bunkers at Lorient, where crews prepared their boats for the next patrol, and where the mathematics of survival had become, for anyone willing to calculate them honestly, deeply troubling. And yet the U-boats kept going. They kept going because until the spring of 1943, they were winning. The tonnage they were destroying was outpacing Allied shipbuilding capacity. Every month, more ships went down than could be replaced. Every month, the arithmetic of the campaign tilted a little further toward Germany. Dönitz had calculated that if his boats could sink 700,000 tons of Allied shipping per month, sustained over a period of 12 to 18 months, Britain would be unable to continue the war. The supply line across the Atlantic would collapse. The island would starve. The American buildup in England would become impossible. The war in Europe would be decided not on any beach or battlefield, but in the cold, dark water of the North Atlantic. In November of 1942, his boat sank 860,000 tons. In the first 20 days of March 1943, during the convoy battles that Hartenstein was participating in, German submarines sank 97 ships in 3 weeks. 97 ships. The British Admiralty, examining those numbers in the last week of March, concluded in an internal memorandum that has since been declassified and archived at the Public Record Office in Kew that the lies were coming, in their precise understated language, dangerously close to losing the Battle of the Atlantic. This was the world that existed before the destroyer Escorts arrived, a world in which German submarines operated in wolf packs of 15, 20, 30 boats, coordinated by radio from Dönitz's headquarters, attacking convoys from multiple directions simultaneously, overwhelming the escorts that protected them, and disappearing into the deep water before the counterattack could be organized. A world in which the convoy escort, typically a handful of aging destroyers and corvettes, was spread so thin across such a vast ocean that a wolf pack could find the gaps and drive through them before the escort commanders could respond. The escort commanders knew what they needed. They had known since 1941. They needed more ships, not better ships, necessarily, not faster ships or more heavily armed ships, though those things would have helped. They needed more ships in the simple arithmetic sense that a convoy of 60 merchant vessels being protected by 4 escorts was a convoy being protected inadequately, and that every ship added to the escort screen was a U-boat deterred or destroy. That would otherwise have been another name on the list of boats that did not come home. The problem was that the ships did not exist. The United States Navy in 1941 and 1942 was building destroyers as fast as its shipyards could manage, but fleet destroyers, the large, fast, heavily armed warships that formed the backbone of naval surface forces, took 18 months to build. From keellaying to commissioning, 18 months was not fast enough. The Atlantic was consuming escort vessels faster than the shipyards could replace them. Something different was needed. Something that could be built faster in greater numbers by shipyards that had never built warships before. The answer came from an engineer in Boston and a set of specifications drawn up in Washington in the summer of 1941 that would, within 2 years, put more than 500 ships into the North Atlantic and changed the mathematics of the campaign so completely and so permanently that Dönitz would later write in his memoirs that the spring of 1943 was the moment he understood Germany had lost the Battle of the Atlantic. Not a battle. The battle, the whole thing, the ship that changed everything was not glamorous. It was not fast. It was not large. It was not the kind of vessel that naval officers of the old school admired or that wartime photographers found compelling. It was 93 meters long, displaced 1,400 tons, and made a maximum speed of 24 knots, which was 6 knots slower than a fleet destroyer and only marginally faster than the surface speed of a surface U-boat. Running on full diesel power, what it had, in abundance, in carefully engineered, industrially produced, standardized abundance, was the ability to find submarines and kill them. And it had that ability not because of any single weapon or any single piece of equipment, but because of the integration of systems that no navy on Earth had yet assembled in a single hull, and that the German submarine service, when it first encountered them in the autumn of 1943, had no doctrine, no tactic, and no technology prepared to defeat. The ship was the destroyer Escort, and the story of how it came to exist and what it did when it arrived begins not in a naval shipyard or an Admiralty conference room, but in a small office in Washington where a 47-year-old naval architect named William Francis Gibbs was staring at a set of requirements that most of his colleagues had already decided were impossible to meet. William Francis Gibbs was not a man who accepted impossible as a final answer. He was born in Philadelphia in 1886, the son of a financier who lost everything in the panic of 1907, and he had spent his entire professional life solving problems that other engineers had decided could not be solved. He had never attended naval architecture school. He had taught himself ship design from textbooks and library books and the kind of sustained obsessive study that produces either failure or genius, and in Gibbs's case had produced the latter with a consistency that made him, by 1941, the most respected naval architect in the United States and one of the most respected in the world. He had designed the SS America, the largest and fastest American ocean liner of her era. He had redesigned the SS Malolo after her near sinking in a 1927 collision, discovering in the process a set of stability principles that would influence merchant ship design for decades. He had an almost physical relationship with ships, the way some men have with music or mathematics, an intuitive grasp of what a hull could and could not do that went beyond calculation into something closer to instinct. When the Navy's Bureau of Ships came to him in the summer of 1941 with the destroyer escort requirement, what they handed him was a document that read like a set of contradictions. They needed a ship that could be built in 6 months instead of 18, that could be built in commercial shipyards with no naval construction experience, that could be crewed by men with minimal training, that would be cheap enough to produce in numbers that the budget could sustain, and that would be effective enough against submarines to actually change the course of the campaign. Fast, cheap, simple, and deadly. Pick any three. The conventional wisdom said, you cannot have all four. Gibbs decided the conventional wisdom was wrong. The key insight was standardization, not standardization in the vague sense that military procurement officers used the word when they meant that parts should theoretically be interchangeable. Standardization in the industrial sense, the Ford Motor Company sense, the sense that meant every single component of every single ship would be identical to the corresponding component of every other ship, machined to the same tolerances, assembled in the same sequence, tested to the same standards, so that a shipyard worker building his 15th destroyer Escort was doing exactly the same job in exactal. Why the same way as a shipyard worker building his first? This was not how warships had ever been built. Warships were custom products. Each one was a variation on a design, adapted to the specific capabilities of the yard building it. modified by the preferences of the naval architects overseeing it, adjusted for the availability of materials at the time of construction. Two ships of the same class built in different yards might share a design, but would differ in dozens of details that made their parts non-interchangeable, and their maintenance procedures subtly different. Gibbs eliminated that. He designed the destroyer Escort, the Everts class, the first production variant, as a system of standardized modules that could be prefabricated in inland factories and shipped to coastal yards for final assembly. The hull sections were identical from ship to ship, the machinery spaces were laid out identically, the electrical systems followed the same routing in every vessel. The weapons mounts used the same fittings, the plumbing used the same fittings, the crew accommodations, such as they were arranged identically so that a sailor transferring from one destroyer escort to another needed no reorientation to find his battle station in the dark. The result was a ship that could be built in an average of 180 days from keel-laying to commissioning, not by experienced naval shipyards, by yards that had been building cargo ships and tugboats and river barges 6 months earlier, by workers who had never welded a warship frame or installed a naval gun mount before the contract arrived. The first Everts-class destroyer escort, USS Everts herself, was commissioned on April 15, 1943. 20 more followed within 60 days. By the end of 1943, American shipyards had delivered 71 destroyer escorts to the United States Navy and transferred dozens more to the Royal Navy under Lend-Lease. By the end of the war, 565 destroyer escorts had been built, 565 ships, each one a standardized iteration of Gibbs's original design, produced at a rate that the German naval staff, when they compiled their post-war assessments, described with a word that appears in several independent documents and that translates, with some loss of nuance, as incomprehensible. Now hold that number, 565, against what Germany had available to counter it. At the peak of its strength in the spring of 1943, the Kriegsmarine operated approximately 140 operational U-boats, 240 submarines against 565 dedicated submarine hunters, each one equipped with technology specifically designed to find and kill them. The arithmetic that Dönitz had been calculating since 1939, the arithmetic that had shown Germany winning the Battle of the Atlantic as recently as March of 1943, had been inverted, not gradually, almost overnight, but the numbers alone do not explain what made the destroyer escort the nightmare that U-boat commanders said it was. Numbers matter. But technology matters more when the technology is sufficiently asymmetric, and the technology that the destroyer escorts carry when they arrived in the North Atlantic in the autumn of 1943 was not merely better than what had come before. It was from a different category of warfare entirely. Oberleutnant Sir C-Class Barkston was 28 years old when he took command of U-521 in the spring of 1943. He had served as a watch officer on two previous boats and had survived experiences that had already killed most of his contemporaries. He was considered one of the more capable young commanders in the U-boat arm, careful where others were reckless, analytical where others were impulsive. His training had prepared him for everything the North Atlantic had thrown at him so far. It had not prepared him for what happened on June 2, 1943, when USS PC 565, an American patrol craft, located U-521 approximately 200 miles east of Cape Hatteras and attacked with a weapon at Barkston, had never encountered before. The weapon was the Hedgehog, and to understand what the Hedgehog meant to a U-boat crew, you first need to understand how submarine hunting had worked before it existed. The standard anti-submarine weapon of the early warriors was the depth charge, a canister of high explosive set to detonate at a predetermined depth, rolled off the stern of an escort vessel or fire from side-mounted projectors. Depth charges worked. They had been working since the First World War. A depth charge detonating within 10 meters of a U-boat's pressure hull would destroy it. Within 20 meters, it would cause serious damage. The problem with depth charges was a technical limitation so fundamental that it had shaped anti-submarine tactics for 20 years and that every U-boat commander had been trained to exploit an escort vessel using ASTIC, the British underwater sound detection system, could track a submerged submarine by bouncing sound pulses off its hull and measuring the return time. As long as the Escort was more than approximately 200 meters from the submarine, ASTIC worked reliably. But as the Escort closed to attack range and ran over the submarine's position to drop its depth charges, it entered a dead zone where the geometry of the ASDIC beam meant it could no longer track the target. The contact was lost in the final seconds before the attack. In those final seconds, the submarine moved, not far, perhaps 50 meters, perhaps 100 meters in the time it took the Escort to cross the attack position, but 50 meters was enough. Depth charges set for the last known position of a submarine that had moved 50 meters in a different direction were 50 meters from their target. They detonated. They caused noise and concussion and psychological terror, but they often did not. KILL U-boat commanders had built their entire survival doctrine around that dead zone. The procedure was refined, drilled, and executed with the precision of men who understood that perfection in this specific maneuver was the difference between surviving the attack and dying in it. When an ASDIC contact was established, the commander ordered a course change, a depth change, and reduced speed to minimize the noise signature. He timed the approach of the Escort by listening to its propellers on the hydrophone. He waited for the moment when the ASDIC ping stopped, the moment the Escort entered the dead zone, and then he executed his evasion, a sharp turn combined with a depth change that put him somewhere other than where the depth charges were going to fall. It was a skill. It was a learnable, teachable, survivable skill. And for the first 3 years of the war, it worked often enough that a skilled U-boat commander could survive multiple depth charge attacks and bring his boat home. The Hedgehog made that skill irrelevant in a single design decision. The Hedgehog was a forward-throwing weapon, a spigot mortar that fired a pattern of 24 small contact-fused projectiles in an elliptical spread ahead of the attacking vessel, not behind it, not to the side, ahead. This meant that the attacking ship could maintain ASDIC contact with the submarine throughout the entire attack run because it never crossed over the submarine's position. The contact was never lost, the dead zone never opened. The submarine commander, listening on his hydrophone, heard the Escort's propellers getting louder, heard the moment the weapon fired, and had approximately 17 seconds before the projectiles hit the water and sank toward him. 17 seconds. There was no evasion doctrine for 17 seconds. There was no course change and depth change combination that could move a submarine far enough in 17 seconds to escape a pattern of 24 projectiles spread across a 40-meter ellipse. The skill that had kept U-boat commanders alive for 3 years was simply insufficient against a weapon that eliminated the dead zone. There was one additional detail that made the Hedgehog psychologically devastating beyond its physical lethality. A depth charge detonated whether it was close to a submarine or not. The sound of a depth charge going off told a U-boat crew nothing about whether they had been hit or missed. The attack was always loud, always terrifying, always damaging to instruments and nerves. Even when it failed to destroy the boat, the Hedgehog projectiles were contact-fused. They only detonated if they hit something. If a Hedgehog attack produced no explosion, the submarine crew knew they had been missed. If it produced an explosion, they knew with certainty that at least one projectile had struck the hull. This meant that when Barkston's hydrophone operator heard the Hedgehog pattern hit the water above U-521 on June 2, 1943, and the first explosion came, followed by a second, followed by a rapid series of further detonations as the projectiles that had struck the hull ignited the ones around them, there was no ambiguity about what was happening. U-521 was dying. Not damaged, not shaken, not in need of repair. Dying. The hull was breached. The water was coming in. Barkston survived because he was near the conning tower hatch, when the attack came, and because he was able to get through it and into the water before the boat went down. He was the only survivor from a crew of 51 men. He was picked up by PC 565, the same vessel that had just killed his boat and his crew, and spent the remainder of the war as a prisoner in the United States. He later wrote about the attack in a memoir compiled after his repatriation in 1946. He wrote that the experience of being hunted by the hedgehog was qualitatively different from anything he had encountered before. He wrote that with depth charges, there was always the possibility of survival, always the chance that the attack would miss, always the sense that skill and training and judgment could affect the outcome. He wrote that the hedgehog removed that sense entirely. He wrote that for the first time in his experience, he felt not like a hunted man who might escape, but like a target who had already been struck before the weapon arrived. That feeling, that specific removal of the possibility of skilled survival, was what the hedgehog gave the destroyer escort crews and took from the U-boat commanders. And the hedgehog was only one of the systems that made destroyer escorts into the nightmare that gave this story its title, because sitting in the destroyer escorts operations room, bolted to the bulkhead beside the Hedgehog fire control station, was a piece of equipment that the German Naval Intelligence Service had been attempting to understand since the first reports of its existence reached Berlin in late 1942. Equipment that had no equivalent in the Kriegsmarine. Equipment that was, in the precise technical assessment of the German naval staff, the single most dangerous development in anti-submarine warfare since the invention of ASDIC itself. The Americans called it HF, DF. The sailors who used it called it Huff-Duff. And the story of what it did and how it worked and why no German engineer had managed to replicate it begins in a laboratory in New Jersey where a British scientist named Robert Watson Waugh TT had sent a set of technical documents in 1940 that the German intelligence service would have given almost anything to intercept. They never did. Huff-Duff was not a weapon. It did not fire anything. It did not detonate anything. It did not damage a submarine or injure a crew or send anything to the bottom of the Atlantic. It was a receiver, a radio direction finder operating on high frequencies, mounted on the mast of a destroyer escort, capable of detecting a U-boat radio transmission and calculating its bearing in approximately 30 seconds. 30 seconds. To understand why 30 seconds was enough to change the entire character of the Atlantic campaign, you need to understand how the Wolfpack system worked and why radio was its central nervous system and its fatal vulnerability simultaneously. Dönitz commanded his U-boats from a headquarters ashore. First from Lorient on the French Atlantic coast, later from Paris, later from Berlin as the war turned and the geography of defeat contracted. His command method was built on radio. Every U-boat at sea reported its position daily. Every sighting of a convoy was radioed to headquarters immediately. Every attack was reported. Every mechanical problem, every weather observation, every request for a supply was transmitted by radio. Dönitz used these reports to build a real-time picture of where his boats were, where the convoys were, and how to position the Wolfpacks for maximum effect. It was a brilliant system. It had produced the greatest submarine campaign in naval history, and it required every U-boat to transmit regularly, which meant that every U-boat was, every time it transmitted, announcing its presence to anyone with a receiver capable of detecting it. Before Huff-Duff arrived in the Atlantic, that announcement was not immediately dangerous. Standard radio direction finding equipment required multiple shore stations to take simultaneous bearings and triangulate a position, a process that took time and produced results that were accurate enough for strategic planning, but not precise enough to vector an escort vessel directly to a submarine. A U-boat that transmitted and then submerged had, in practical terms, disappeared before anyone could act on the bearing. Huff-Duff changed that in one specific way that made all the difference. It was shipborne. It was on the escort vessel itself. It did not need shore stations. It did not need triangulation from multiple positions. It gave the escort commander a bearing to the transmitting submarine in 30 seconds. A bearing accurate enough to steer toward, accurate enough to bring the ship's aspect into range, accurate enough to begin an attack. A U-boat that transmitted while a Huff-Duff-equipped escort was within range had, in the 30 seconds it took to send its message, told the escort exactly where it was. Commander Kenneth Knowles, who served as the head of the United States Navy's submarine tracking room in Washington from 1943 onward and who compiled the most comprehensive American assessment of the Atlantic campaign after the war, wrote in his final report that Huff-Duff was responsible for more U-boat kills than any other single piece of equipment deployed in the campaign. Not the Hedgehog, not improved depth charges, not air cover from escort carriers. Huff-Duff, because Huff-Duff found the submarines at the other weapons then destroyed. The Germans knew Huff-Duff existed by early 1943. They had captured enough Allied documents and interrogated enough prisoners to understand the principle. What they could not understand, and what their own engineers spent months attempting to replicate without success, was how the Allies had miniaturized the equipment sufficiently to fit it on a destroyer escort and how they had made it sensitive enough to detect the brief, compressed radio bursts that experienced U-boat operators used to minimize their transmission time. The answer was a combination of British scientific development and American manufacturing capability. Had produced, by 1943, a receiver so sensitive and so compact that it could be installed on any vessel large enough to carry its antenna array. The British had developed the theoretical basis. American factories had built it at the scale required to equip every destroyer escort in production. Thought by the end of 1943, every destroyer escort leaving an American shipyard carried Huff-Duff as standard equipment, not as an option, not as a special fitting for selected vessels, standard. Every one, 565 ships, every one of them carrying a receiver that turned a U-boat's radio transmission into a death sentence. Captain Lieutenant Hartenstein, the man we met in the opening of this story, did not survive to read Knowles's report or to understand what had changed in the Atlantic in the months after the convo battles of March 1943. He died on March 8, 1943, 8 days before the Great Convo battle reached its peak, when U-156 was attacked and sunk by an American B-4 Liberator aircraft in the Caribbean. He was 34 years old. He left behind a wife in Plough and a record of service that included the sinking of 20 Allied ships and one of the most controversial incidents of the submarine war, the Laconia Affair of 1942, in which he had attempted to rescue the survivors of a British troopship he had just torpedoed and had been attacked by an American aircraft while doing so, with survivors in the water around him. History is rarely simple about men like Hartenstein. He was a skilled officer in a campaign that killed 30,000 Allied merchant sailors and approximately 28,000 U-boat crewmen. He tried, on one documented occasion, to save the lives of the men he had just put in the water. He died before he encountered the destroyer escorts that would have made his skills insufficient. In a different sense, he was lucky. The men who came after him were not. By May of 1943, 2 months after the convo battles that had seemed to confirm Germany's grip on the Atlantic, the campaign had turned so completely that Dönitz withdrew his remaining boats from the North Atlantic entirely. In that single month of May 1943, Allied forces sank 41 U-boats, 41 submarines in 31 days, nearly 1 boat per day. The crews of those 41 boats, approximately 2,000 men, died in the cold water or in the crushed steel of their hulls at the bottom of the Atlantic. Dönitz called May 1943 Black May in his memoirs. He wrote that the losses were unsustainable. He wrote that the tactics that had worked for 3 years had ceased to work with the suddenness that his staff had not anticipated and could not immediately explain. He wrote that something had changed in the Allied anti-submarine capability in a way that made the continuation of Wolfpack operations against escorted convoys no longer viable. What had changed was the destroyer escorts. not exclusively, a closing of the Atlantic air gap by long-range aircraft, the deployment of escort carriers, the improvements in Allied convoy routing intelligence from the Ultra program, all of these contributed. But the destroyer escorts were the foundation. They were the ships that made everything else possible. They were the hulls that carried the Hedgehogs and the Huff Duff and the improved depth charges and the trained crews and the coordination doctrine that turned the Atlantic from a German hunting ground into a killing field for U-boats. After Black May, Dennett sent his boats back to the Atlantic with new equipment, including a radar detector called the Naxos that was supposed to warn U-boats when they were being tracked by Allied radar, and a new anti-aircraft armament designed to allow submarines to fight back against aircraft on the surface rather than diving. Neither innovation restored the balance. The Naxos detected some Allied radars, but not the specific frequencies used by the most advanced sets. The anti-aircraft guns produced occasional successes against aircraft, but invited surface counterattack by escort vessels that the U-boats could not outrun or outfight. The fundamental problem was not solvable by incremental improvements to the U-boat. The fundamental problem was that the destroyer escort had been designed from the beginning as a system, not a ship. And a system cannot be defeated by improving one component of the thing it was designed to defeat. A U-boat commander who avoided Huff Duff by minimizing his radio transmissions lost the coordination with other boats that made Wolfpack tactics effective. A U-boat commander who dived immediately to avoid the Hedgehog lost the ability to track the convoy on the surface. A U-boat commander who stayed deep to avoid sonar ran his batteries down and had to surface, where the Huff Duff was waiting. Every tactic that mitigated one threat exposed the boat to another. The system had been designed to create exactly that. Impossible geometry. Gibbs had understood this when he drew up the specifications. Knowles had understood it when he deployed the ships. The young officers who commanded those destroyer escorts understood it when they trained their crews. The U-boat commanders understood it only when they encountered it, which was usually too late. The final numbers of the Battle of the Atlantic tell the story in the language of mathematics that Dennett had used to plan his campaign. Of the 1,162 U-boats that Germany commissioned during the Second World War, 785 were lost on operations. Of the approximately 40,000 men who served in U-boats during the war, 28,000 did not come home. The casualty rate for U-boat crews, approximately 70% of all men who served, was the highest of any military branch in any nation in the war, higher than German infantry on the Eastern Front, higher than Japanese kamikaze pilots, higher than any comparable cohort in the entire conflict. Against that, the destroyer escorts and the broader Allied anti-submarine campaign had protected the supply line that fed Britain, equipped the Allied armies, and made the invasion of Europe possible. The 2,779 ships that Germany sank were a grievous loss. The ships that Germany did not sink, the millions of tons of cargo that crossed the Atlantic safely under the protection of escort vessels, were the margin by which the war in Europe was won. And this is the answer to the question this story has been building toward, not why German submarine commanders called American destroyer escorts their worst nightmare, which is the simple answer of Hedgehogs and Huff Duff and 565 ships arriving faster than any navy had ever built warships before. The real answer is deeper than that. The real answer is about what those ships represented. Germany built U-boats the way Germany built everything, with precision, with craftsmanship, with the genuine pride of men who understood their work and did it superbly. Each U-boat was a masterpiece of German industrial capability, hand-fitted, carefully tested, individually commissioned. The men who crewed them were trained to a standard that no navy in the world exceeded. America built destroyer escorts the way America built everything, at scale, with standardization, with the industrial logic of a country had decided the way to win was not to build the best single ship, but to build 565 ships that were good enough, fast enough, and identical enough to be crewed. maintained, and deployed by men who had been civilians 6 months before. The nightmare was not the hedgehog, the nightmare was not the Huff-Duff, the nightmare was the realization, arriving too late for most of the men who had it, that Germany had brought craftsmanship to a war that was being decided by arithmetic, that the opponent had understood something about industrial civilization at the Third Reich, for all its genuine engineering capability, had never grasped. You do not win a war of attrition with masterpieces, you win it with enough. Klaus Barkstein, the sole survivor of U-521, was repatriated to Germany in 1946. He worked for several years in the West German Merchant Marine and later became a shipping executive. In Hamburg, he gave several interviews to naval historians in the 1960s and 1970s and was consistently generous with his recollections, describing both the genuine comradeship of U-boat service and the particular terror of the hedgehog attack that had killed his crew. He died in 1997 at the age of 82. He was the last surviving U-boat commander to have experienced the transition from the early war years, when the Atlantic belonged to Germany, to the years when it did not. William Francis Gibbs continued designing ships after the war. His greatest post-war achievement was the SS United States, launched in 1952, which captured the blue ribbon for the fastest Atlantic crossing and held it until the era of commercial jets made the record irrelevant. He was obsessive about fire safety, a fixation born from studying the disasters that had killed passengers on earlier liners, and the United States was built with almost no flammable material anywhere in her construction. Gibbs died in 1967. He never received a military decoration for the destroyer escort program, though the ships he designed likely saved more Allied lives than any single weapon system of the war. He would not have minded. He was an engineer. The ships worked. That was enough. Kenneth Knowles, the man who tracked every U-boat in the Atlantic from his Washington operations room and who understood better than almost anyone alive what the destroyer escorts had accomplished, retired from the Navy in 1952 and worked for several years as a consultant before his death in 1994. His submarine tracking room, a windowless space in the Navy Department building where he had moved pins on a map for 3 years. How the Atlantic campaign turned, was dismantled. After the war, the map is gone, the pins are gone, the room is something else now. The 28,000 U-boat crewmen at the bottom of the Atlantic are still there. Admiral Carl Dennett survived the war, was convicted at Nuremberg of war crimes related to unrestricted submarine warfare, and served 10 years in Spandau prison. He was released in 1956 and lived until 1980, long enough to see his memoirs published, his decisions debated, and the men who had served under him grow old and die. He never, in any interview or written document, adequately explained why he had continued sending boats into the Atlantic after Black May, when the mathematics of survival had become what they were. Perhaps there was no adequate explanation. Perhaps the answer is simply that the system he commanded had been built for a war that the other side had decided to fight differently, and that by the time he understood the difference, there was nothing left to do but count the boats that did not come home. Thank you for staying with this story all the way to the end. If it gave you something, a detail you had not considered, a name you had not heard, a way of understanding the Atlantic campaign that the standard histories do not reach, a like helps more than you might think. It tells the algorithm that this kind of deep, documented history has an audience. It helps these stories find the people who are looking for them. If you are not subscribed yet, I would be honored to have you here. Hit subscribe and the bell so you do not miss what comes next. There are more stories like this one, stories about the quiet things, the technical things, the things that happened in laboratories and shipyards and operations rooms that decided battles before a single shot was fired. I want to know where you are watching from today. Leave it in the comments below, and if someone in your family served in the Second World War, on any ocean, in any ship, in any navy, tell me about them. These stories belong to the people who lived them, and to the families who remember them. I would be honored to hear.